If you recall, there was a single slit. The width of the slit is E. We allow the plane wavefront to incident on it. Then what happened? When the wavefront came in the plane of the slit, most of the portion of the wavefront got blocked. A small portion of the wavefront was allowed to only pass through the slit. When that wavefront, the unblocked portion of the wavefront that came in the plane of the slit, every point of the wavefront that acted as a new source and sent secondary waves in all directions. From every point such secondary waves, they started propagating. So what we did, then after that we kept a lens. So what lens did? Lens, in the focal plane of the lens, we kept a screen. And these secondary waves, those are bent at theta with the incident direction. They were made to superpose at a particular point by the lens. Such infinite number of secondary waves bent at theta, they are made to superpose at a point on the screen. And as we have discussed, the resultant intensity at P is given by I equal to I0 sin square alpha by alpha square. And what is alpha? Alpha is equal to pi sin theta by lambda. So this is what we have got. Then we wanted to know, you see, alpha is a function of theta as well as I is a function of alpha. So obviously, I is a function of theta. So all the secondary waves who are bent at different angles, they will have different theta and they will superpose at different points. Because of theta, the path difference will be different and hence alpha will be different, so as well as I. That's why what you will see on the screen is a non-uniform intensity distribution pattern. And this non-uniform intensity distribution pattern you are getting due to superposition of secondary waves. That's why this is diffraction. Had you been seeing the non-uniform intensity distribution pattern due to superposition of primary waves, you would have called it interference. But this is what you are getting, the non-uniform intensity distribution pattern due to superposition of secondary waves. That is the reason why we call this as diffraction. Now we wanted to calculate, estimate the positions where maxima will be seen. So first of all, we discussed about principal maxima. Now, I showed you in the last class, if I plot sin square alpha by alpha square with alpha, the graph goes like this. A very huge maxima at alpha equal to 0. So it is obvious that this maxima will have the maximum intensity. And this tells us that at alpha equal to 0, there will be a maximum. But in that case, when alpha tends to 0, sin alpha by alpha is equal to 1. So I becomes I0 sin square alpha by alpha square, which is equal to I0, the maximum intensity. And when alpha tends to 0, pi sin theta by lambda is equal to 0 because pi is a constant whose value is non-zero. E is the width of the slit non-zero. Lambda is the wavelength of the wave that is illuminating the slit, that is non-zero. So obviously sin theta is to be 0, giving you theta is equal to 0. So what this suggests? This suggests that all secondary waves who are originating from the plane of the slit and superposing at a point T0 state, they will have no path difference between them, they will superpose in phase and the intensity will be maximum, particularly of this value. You can take this as I0 from this to this. So at theta equal to 0, whatever secondary waves they will propagate, they will superpose at a point P0 on the screen, and there you will get a maximum. That is what we call as principal maximum, but mostly instead of principal maximum, that is called as central maximum, because it is symmetric to the size of the screen. So that is why it is called as central maximum. This is what we have done in the last class. Now we want yes. Any question? Any question from anyone? Anyone wants to ask any question? Hello, सो गए क्या?
No, sir.
Oh, no response. Vaishnavi.
Yes, sir.
All of you go video में देखने के लिए. All of you come to video. Those who will not be in video, their attendance will be deducted, and at least 5 marks for this class will be deducted.
Sir, कर लिया video on, sir.
हाँ, yeah, Satyavrat, you come to video. Everybody come to video.
वीडियो ऑन करके रखना पड़ेगा सर?
हाँ, रखना पड़ेगा.
सर
वीडियो ऑन करके रखना पड़ेगा.
सर
मैं देखता हूँ कौन वीडियो में नहीं आ रहा है. Still many are not in video. नाम पुकारूं क्या? समुद्र नील, सुयास, मैं नोट करके रख रहा हूं एक एक.
सर यस सर.
नहीं, तुम वीडियो में आओ. वो यस सर नहीं चलेगा.
ओके सर वेट अ मिनट.
प्रखर चंडेल, आर्य,
सर ऑन है नहीं है क्या?
आदर्श,
ऑन है सर.
ऑन है सर.
अभिजीत,
खराब है थोड़ा.
तुम्हारा ऑन है, कुछ भी है, मेरे को नहीं दिखा मतलब तुम्हारा ऑफ है.
सर अभी दिखाई दे रहा है ना?
वैष्णवी,
Yes, sir.
वैष्णवी 2, भव्या, अंकित सिन्हा, many are doing mischief. Okay, अभी मैं रोल नंबर keep video on. Let me take your roll numbers, those who are not in video. रवि राज, प्रेमचंद्रा, हाँ प्रेमचंद्रा भी आया.
Sir, my video is on, sir. My video is
शशि, सिद्धांत, प्रखर चंडेल, ये लोग सब वीडियो में नहीं है.
सर ऑन है. सर ऑन है.
क्या ऑन है?
सर ये 70 का ऑन है.
किसी का क्लास के टाइम में रेस्पॉन्स नहीं सुनाई दे रहा है.
सर ऑन
अभी
है.
ये लास्ट टाइम के लिए तुमको वीडियो ऑफ करने के लिए परमिट कर रहा हूँ. आगे अगर रेस्पॉन्स ठीक से नहीं आया मतलब फिर मैं जब भी बोलूंगा कुछ पूछूंगा, यू हैव टू रेस्पॉन्ड इमीडिएटली.
Yes, sir.
You can remain out of video. You can remain out of video, but anytime if you are not responding, you will be in problem. I am telling you.
Okay, sir.
Don't tell me after that. So what we are now going to do is we are trying to get the minimum positions. Minimum. Now we are saying I is equal to I0 sin square alpha by alpha square. I0 चलना कीजिए. Now then I will be 0 only when sin square alpha is 0, because when numerator is 0, then the fraction also vanishes. So this requires that minimums are formed when sin alpha is equal to 0. But you know when sin alpha is equal to 0, that means the value of alpha is equal to plus minus n pi, where n is equal to 0, 1, 2, etc. But n equal to 0 is not permissible. Why n equal to 0 is not permissible? Because if you take n equal to 0, alpha is equal to 0, alpha equal to 0 already giving you the principal maxima. So because alpha equal to 0 gives you principal maxima, that's why n equal to 0 is not acceptable. The minimum start with n equal to 1 onwards. So these are the positions in fact where you can see the minimum. So what you get then finally, sin alpha equal to 0, but alpha not equal to 0. This is the condition for minimum. Now then alpha has to be plus minus n pi, where n is equal to 1, 2, 3, etc. As I have told you, n equal to 0 is not allowed because that will give you central maxima. Okay. Then alpha equal to plus minus pi, alpha equal to plus minus 2 pi, alpha equal to plus minus 3 pi. These are the positions of alpha where you will get the minimum. This is n equal to 1. So that's why this is called as first order maxima, a minimum. N equal to 2. This is called as second order minimum. N equal to 3. This is called as third order minimum, and so on. Now, minimums occur with I equal to 0 when alpha is equal to plus minus n pi, with n equal to 1, 2, 3, etc. But what is alpha? Alpha is equal to pi sin theta lambda. So this is equal to plus minus n pi. You cancel pi from both sides. So what you get is e sin theta is equal to plus minus n lambda. If you recall properly, this is the condition that you had read also in your 12th class. In wave optics chapter while discussing the single slit diffraction pattern, there it was mentioned that the condition for minima was e sin theta equal to plus minus n lambda, where n equal to 1 corresponds to first minima, n equal to 2 corresponds to second minima, and so on. Now, what can be the possible question? We can proceed first from numericals here. Some potential numericals that may have like which you may expect question in examination. So the problem goes like this: you have a slit. The slit has width E. You have allowed a plane wavefront to incident on it, and waves from every point on the slit, they proceeded in all directions. You have kept the lens behind. In the focal plane of the lens, you have kept a screen. What you saw, all secondary waves, those are moving in the same direction as the incident wave, they will superpose at a point which you call as the central maxima. So this is P0, which is the central maxima position. Now you want to locate the minima, and the minima is equal E sin theta equal to plus minus n lambda. If you put n equal to 1, what you get is E sin theta equal to plus minus lambda. Then theta becomes sin inverse plus minus lambda by E. So this is the condition for theta at which you expect the minimum. This is n equal to 1. So if theta is equal to this, say theta equal to theta 1, satisfying this condition, all the waves those are bent at theta 1, they will superpose at a point, giving you the first minima. But you can look at the plus sign as well as minus sign. Because of minus sign, all waves those bent at theta down, they also superpose at a point where you see first minima. And at first minima, it is obvious that the intensity will be zero. Whereas the central maximum, the intensity is maximum. Actually, what happens when you look at the screen with your naked eye, you see maximum intensity at central maxima P0. But when you look away from P0, जब आप P0 से थोड़ा दूर देखते हो, तो intensity goes on decreasing, intensity घटता जाता है. और ठीक first minima के जगह पे, at this first minima, the intensity becomes zero. So practically, whenever a common man looks at the screen, he sees light in this region, over this region. He thinks that the central maxima spreads from this point to this point. But practically, the central maxima is formed at one point. But it appears to the common man because light spreads from here to here, minima to minima. So it appears to him as if the central maxima is spread from this to this. So this is why this is called as, you can say this is first minima. First minima, this width is called as width of central maxima. This is of course linear width. And you know this is equal to focal length of the lens. Normally the lens is kept very close to the slit. This distance is negligibly small. So you can effectively think of that the distance between the slit and the screen on which you are seeing the diffraction pattern is equal to the focal length of the lens, effectively. In that case, if I draw the same diagram again, this is the single slit, I am showing the lens, this is the screen, you see the principal maxima here, you see the vast minima at a point, having this angle is equal to theta 1, satisfying this condition. On the other side also you see, again at same theta 1, another first minimum. The linear width of the central maxima is supposed to be this. We call this as the angular width of central maxima. So the angular width of central maxima is practically the angle at which the first minima forms into 2. So you can write angular width of central maxima is equal to 2 theta 1, and because theta 1 is radian sine inverse lambda by E, so you can write this as 2 theta 1 as 2 into sine inverse lambda by E. So if someone asks you what is the angular width of the central maxima, you have to know lambda and E. And if you want to get the linear width, because you know this is approximately equal to focal length, you have measured this in radian unit. So the linear width of central maxima is given by W is equal to F into 2 theta 1, F into 2 theta 1. So you can write this as 2F sine inverse lambda by E. Many times it is asked to calculate the linear width of the central maxima, then this formula is useful. Okay, when you will say that there is a diffraction, you see, this is the size of this slit. If the size of the central maxima, if the width of the central maxima is more than the size of the slit, अगर central maxima का width slit width से ज़्यादा है, तो ये लगेगा कि लाइट इफेक्टिवली बेंड हुआ है. So And for this to see what you need is theta 1 should be large. I can give you an example here. Let you take रुको थोड़ा गरम का दिन है ना, जल्दी जल्दी सूख रहा है। Let E is equal to the width of the strip. E is equal to take 100 lambda for an example. Then what will be theta 1? Theta 1 will be equal to sin inverse E by lambda. So this is sin inverse 0.01. You can use the calculator to check what will be the value of sin inverse 0.01. Just I am checking. अरे sin inverse तो निकल नहीं रहा है। देखो तो sin inverse निकालो तो मेरे पास कैलकुलेटर जो है वहां पे sin inverse नहीं निकल रहा है। कितना आएगा sin inverse 0.01? How much time you are taking? Sin inverse 0.01. You must have the calculator with you.
सर
हाँ बोलो।
सर वो ई बाई लैम्डा होगा या लैम्डा बाई ई होगा सर?
Oh, sorry, lambda by yes. So that is equal to 0.01. Sin inverse 0.01. How much it is? How much time you are taking?
0.57 degrees.
Zero 0.5729. So this is equal to 0.5729 degree. That means less than 1 degree. What it means? It means that the first minimum will be formed at less than 1 degree. Both sides. That means the central maxima will have the width same as the width of the single slit. So in that case, it will not appear to you that the light has bent. Light is seen to be bent only when you see that the size of the central maxima is much more than the size of the slit. Another example, let E equal to 2 lambda. In that case, theta 1 is equal to sin inverse lambda by E. So sin inverse R. And as you know, sin inverse R is equal to 30 degree. So all those secondary coils who are bent at 30 degree, they are superposed at some point, whereas the first minima will be below. That means the central maxima will be much more than the width of the slit. So bending of light will be prominent. So if you want to see the bending of light prominently at single slit, you need the size of the slit should be comparable to the size of the wavelength. That is what I was telling earlier. To see prominent diffraction pattern, you need the size of the slit to be comparable to the size of the wavelength of the incident light. Now, after you see the positions of central maxima and minima, let us see what is the position of secondary maximum? So what are the values of alpha for which secondary maxima will be formed? We know I is equal to I of sin square alpha by alpha square. Now what we want I to be maximum. You know, a quantity becomes maximum when it becomes maximum, its derivative is zero, even at minimum. So if you want to get secondary maxima, you have to find out di by d alpha to be zero. If you take the di by d alpha, this becomes I0. 2 sin alpha into cos alpha minus, this is the derivative of sin square alpha. Okay, first numerator का derivative into denominator minus denominator into denominator का derivative into numerator. By denominator का square. So this should be equal to 0. Now this is 0 only when the numerator is 0. So this implies that 2 sin alpha into cos alpha into alpha square minus 2 alpha sin square alpha must be equal to 0. So this implies that alpha sin alpha within bracket 2 you can take outside, there will be alpha cos alpha, there will be 1 sin alpha here, is equal to 0. So if you take di by d alpha equal to 0, you get 2 alpha sin alpha into this quantity equal to 0. Now, when this is equal to 0, alpha is a variable, that means either alpha is 0 or sin alpha equals to 0 or alpha cos alpha minus sin alpha equal to 0. Alpha equal to 0 already has given you central maxima. Sin alpha equal to 0 already giving you position of minima. So it is obvious that the position of secondary maxima may come from here. That means alpha cos alpha should be equal to sin alpha, giving me tan alpha. Sin alpha by cos alpha is tan alpha. Tan alpha is equal to alpha. So any alpha that satisfies this condition will give you the positions of theta, values of theta for which secondary maxima will occur. जिस अल्फा के लिए ये कंडीशन सेटिस्फाई होगा, उस अल्फा में आपको सेकेंडरी मैक्सिमा मिलेगा. तो अल्फा का वैल्यू निकालने के लिए सेकेंडरी मैक्सिमा का यू हैव टू सॉल्व दिस इक्वेशन, बट दिस इज नॉट सॉल्वेबल. This is a transcendental equation. You cannot solve it theoretically. So you have to go by the graphical procedure. How you go by the graphical procedure? Suppose you have a function like, एक एग्जांपल बोलता हूँ, x square plus 2 is equal to x minus 1 का होल स्क्वायर. ग्राफिकली इसको सॉल्व करो. तो आप क्या करते हो? x square plus 2 को ग्राफ में प्लॉट करते हो, उसी ग्राफ में इसको भी प्लॉट करते हो, और दोनों जहां पे इंटरसेक्ट करते हैं वो होता है that x value at which both these are satisfied. So if you want to solve this graphically, you have to plot a graph of alpha versus alpha and tan alpha versus alpha. So let us plot that. पहले tan alpha versus alpha प्लॉट करते हैं. We know the tan graph. So this is alpha equal to 0. Suppose this is pi by 2. This is pi. This is 3 pi by 2. This is 2 pi. This is 5 pi by 2. Similarly, here it is minus pi by 2. Minus pi. minus 3 pi by 2, minus 2 pi, and so on. Now you draw vertical lines here. Because you are going to plot the tan graph. You know what is a tan graph? Tan graph goes like this, minus pi by 2 to plus pi by 2. Plus pi by 2 to 3 pi by 2. 3 pi by 2 to 5 pi by 2. Minus 3 pi by 2 to 5. And so on. So this is the tan graph. Then you plot alpha equal to alpha. Alpha equal to alpha will be a straight line passing through the origin at 45 degrees. So this is alpha equal to alpha and this is tan alpha. You can mark the points are there intersecting. This is one point where alpha equal to 0 and that is the central maxima. Nothing more you are. But you can see another point here. At this point, tan graph and alpha equal to alpha graph are intersecting. This is a position which corresponds to alpha at which a maxima occurs. This is slightly less than 3 pi by 2. But you can approximately say alpha equal to 3 pi by 2 approximately will give you a maxima position. Similarly, another cutting point you can see here, that is at 5 pi by 2 here. So in that case, alpha is approximately equal to 5 pi by 2. So if you look at like this, what you see is alpha is equal to 2n plus 1 into pi by 2 is the condition for secondary maxima to form. Now what is alpha? Pi sin theta by lambda. So this should be equal to 2n plus 1 into pi by 2. Pi cancels out. E sin theta is equal to 2n plus 1 into lambda by 2. This is the condition for secondary maxima. That is what you have read in your 12th class also. Now, if you want to see what are the intensities, आप अगर central maxima पे जाओगे, the intensity is equal to I0. That is what we have seen. First maxima के लिए alpha is equal to plus minus 3 pi by 2. So I is equal to I naught sin square alpha by alpha square. Put these values. I naught sin 3 pi by 2 divided by 3 pi by 2 का whole square. So this is equal to approximately 1. And 4 by 9 pi square into I0. You see, this is, if you calculate this will be I0 by 22.2. So whatever intensity you get at central maxima, the intensity at first maxima is 1 by 22.2 times. That means very less. If you go to second maxima, that occurs when alpha is equal to plus minus pi by 2, then I is equal to I0 sin square alpha by alpha square. Put the value of alpha equal to 5 pi by 2. You will get I0 sin square 5 pi by 2 divided by 5 pi by 2 का whole square. So this will be equal to 4 by 25 pi square of I0, which is 1 by 61.1 plus I0. You see how the intensity is decreasing very fast as you go to other maxima. So, if you plot the graph, suppose you are plotting I versus alpha graph, the central maxima alpha equal to 0 has a very high maxima, and at pi you get minima, then again there will be a maxima but of less height. So if this is I0, this side is I0 by 22.2. Then here it will be 2 pi. Then again 3 pi. You can mark the intensity is reducing. So this is how you can plot the graph. Many times question comes to plot the intensity versus angle graph. You see, when you take alpha equal to pi, theta becomes sin inverse lambda by e. Similarly, for 2 pi, for 3 pi by 2, all these values you can get easily. So you can plot the intensity versus alpha graph, or you can plot the intensity versus theta. Finally, I want to tell you one thing before I finish this single slit. Suppose this is the single slit. This is the screen. Now, straight you get the central maxima. At theta 1 you get the first minimum. At theta 2 you get the second minimum. So obviously here you get the first secondary maxima. That means what? As we have discussed, this is the width of central maxima. From here it is the minimum. From here light starts, maximum light, then again decreases, here minimum light. Again from here the light starts, becomes maximum, then again decreases. So this is the width of first secondary maximum. This angle, which is theta 2 minus theta 1, is the width of angular width of first secondary maxima. And if you want to get the linear width is equal to L into theta 2 minus theta 1. Where theta 2 is the angle for second minima, theta 1 is the angle for first minima. If you have any question on this, you can ask. You may be asked to get the angular size of the different secondary maxima, or you may be asked to get the linear width of the different secondary maxima. If you have any question on this, you can ask me.
No, sir.
So is it clear?
Yes, sir.
Can you do any question on single slit diffraction?
Yes, sir.
I can share you the note that I have earlier posted in the classroom. These all we have discussed. This is all about the single slit diffraction. Diffraction by a single slit. You can mark on the screen how the pattern will be obtained. It is in the right hand side when you use the red light approximately. These are all discussions. This is the intensity distribution curve, principal maxima, condition of minima and minimum intensity pattern, and then secondary maxima. And this is the graph to solve tan alpha equal to alpha graph equation. This is the final intensity distribution pattern that is seen on the screen due to a single slit. And I have already shown you how you can compare the intensity of the central maxima with the intensity of the secondary maxima with the intensity of the second secondary maxima, and so on. This is the question in general. Actually, the whole question you will not get in the examination. A part of it. With necessary theory, discuss the features of Fraunhofer diffraction pattern through a single slit when it is illuminated by monochromatic light. Draw separately the intensity distribution in Fraunhofer single slit diffraction pattern with respect to the angle of diffraction with respect to distance from the central maximum, so that the relative intensities are given by this ratio. So if you do this neatly, at least you will get nearly the long question, but there are so many other things also you have to work out, like the width of the central maxima, the width of the first secondary maxima, positions of the secondary maxima, the central maxima, and the minima, etc. So I hope you will go through them. Tomorrow I will start diffraction grating, and I have planned to finish that within 2 classes. In this week only, I will finish laser also. So if needed, I may take one extra class. Laser will be finished, of course. Then only big thing will be remain, that is your electromagnetic waves. Because other things, the elasticity portion and the magnetism part, they are very small portion actually. So any question if you have, otherwise we are going to close the class. Any question from anyone?
No, sir.
Any question?
No, sir.
Okay then, bye.
Bye bye, sir.
Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.